Okay, now I'm going to introduce the quotient rule kind of in the same fashion that I introduced the product rule for you. So again, this is not the practical approach, but I think it'll show you that the quotient rule works. Alright, let's say you wanted to find the derivative of the quotient x to the 8th over x cubed. Now again, we know if we simplified that, we would get x to the 5th. And then of course you could use the simple power rule and get y prime is 5x to the 4th. But if you did what I mentioned earlier and incorrectly applied a rule to this, let's say you incorrectly, and notice the word incorrect, you incorrectly thought that this was the derivative of the top divided by the derivative of the bottom. Well, the derivative of the top is 8x to the 7th. The derivative of the bottom is 3x squared. Well, you would get 8/3 over x to the 5th for the derivative. And of course, that is incorrect, right? So that is the incorrect way to do that. The reason is because just like with the product rule, mathematicians have developed a quotient rule to find the derivative of the quotient of two functions using the definition of the derivative. And this rule goes like this. If you want to take the derivative of the function f of x divided by the function g of x, then what you would do is you would take the function g of x times f prime of x minus f of x times g prime of x all over g of x quantity squared. Now, the shorthand notion for this would be if you want to take the derivative with respect to x of the function u, where u is f of x, over the function v, where v is g of x, then that would be v u prime minus u v prime over v squared. Now, the most difficult part of this rule to remember is the numerator. The denominator is pretty easy to remember. You're just going to square the v function. But the numerator, you must get it in the right order. If you get it in the wrong order, you're going to get it wrong. So this is not like the product rule where you can get it backwards and still be correct. You've got to have your first term has got to be v times u prime, and then when you subtract, you're subtracting u times v prime. And so now let me go ahead and show you how that works with this example up here. So now let's apply this rule down here to the function x to the 8th over x cubed. So u would be the numerator, x to the 8th, and v would be the denominator, x cubed. So u prime would be 8x to the 7th, while v prime would be 3x squared. Well, using the shorthand rule, if I say v u prime, I have x cubed times 8x to the 7th, and then minus u v prime, I'd have x to the 8th, that's an 8, x to the 8th times 3x squared, and then all divided by v squared, and v is x cubed, so that would be x cubed quantity squared. Well, if you multiply these two together, these two factors together, you get 8x to the 10th. And if you multiply these two factors together, you get minus 3x to the 10th. So 8x to the 10th minus 3x to the 10th is 5x to the 10th. And then in the denominator, if you square this, you get x to the 6th. So 5x to the 10th divided by x to the 6th is 5x to the 4th, which is indeed the correct answer. So we know that's the right derivative because when we did it the more practical way, we got y equals x to the 5th, and the derivative of that is 5x to the 4th. So this method does work. Now, but of course, you really want to use this rule on problems that can't be simplified, like this one. Here we have f of x equals 5x minus 7 over x squared plus 3. So what I need to do is I'm going to take v, which is the denominator, x squared plus 3, and multiply it by the derivative of the numerator, 5x minus 7. And again here, you can do this in your head after you practice a couple. So there's the derivative, u prime. And then minus u, which is 5x minus 7, times the derivative of v. So here I'm just going to show you that I'm about to take the derivative of v, and then all over v squared. So this right here is the denominator squared. Well, once you get that written, then I'm going to have x squared plus 3 times the derivative of this, which is just 5. So I have x squared plus 3 times 5 for the first portion, and then minus 5x minus 7 times the derivative of this, which is 2x. So that's 5x minus 7 times 2x, and then all over x squared plus 3 quantity squared. If you'll notice up here, I went ahead and multiplied 5 times this binomial and 2x times this binomial. So I get 5x squared plus 15 minus the quantity 10x squared minus 14x. Well, if you distribute the minus through, that's going to be minus 10x squared. So you're going to have 5x squared minus 10x squared, and that's going to give me this minus 5x squared here. And then when you distribute the minus through the negative 14x, you're going to get plus 14x. And then, of course, you also have the plus 15 to go with it. So the final answer here for the derivative of that quotient is minus 5x squared plus 14x plus 15 over x squared plus 3 quantity squared. Okay, this example is very much like the one I just did. So if you need to, freeze the video and go through my steps and see if you can get the derivative. Notice that u is 1 minus 3x, and I've got this written backwards here. So the answer is correct, but I've got the I had the terms backwards here. So u is 1 minus 3x, and u prime is minus 3. And then v is 2x minus 5, and v prime is negative 2. So then on the top you do v, which is 2x minus 5, times u prime minus 3, and then minus u, which is 1 minus 3x, times v prime, which is actually, I said minus 2. It's actually 2, not minus 2. So 2. And then you simplify that numerator, and then of course on the denominator you have it divided by v squared, which is 2x minus 5 quantity squared. So your final answer there is 13 over 2x minus 5 quantity squared. Now, this other one's a little bit more complicated because in the numerator I don't have a polynomial, I have a radical function. X to the 1/3, of course, is the same as the cube root of x. So on this one, I'm going to say u is x to the 1/3, and you know that u prime is 1/3 x to the negative 2/3 using the simple power rule. And then v is the denominator, x squared plus 1, and v prime would simply be 2x. So basically what I'd have to do here is I would have u, which is, let's see, v, I'm sorry, not u, v, I'd have v, which is x squared plus 1, and then I multiply that by u prime, which is 1/3 x to the negative 2/3, and then I have minus u, which is x to the 1/3, times v prime, which is 2x. Well, this one can be a little bit tricky to simplify, but here, let me just see if I can show you what we're going to do to simplify this. So what I'm going to do is I'm going to factor 1/3 x to the negative 1/3 from the top and bottom. So what that means is I'm going to factor from this first term, I'm going to factor out this portion, this 1/3 x to the negative 2/3. Now if I factor that out, I'm just left with x squared plus 1. Okay, I said top and bottom. I'm not really doing the top and bottom, I'm just doing the top. Okay, now I'm going to factor that out of this term, and this is where it gets a little tricky. But remember, when you factor something out, you're actually dividing it into it to get the result. So if I divide this by 1/3, it would be the same as multiplying it by 3. So that's where that 3 comes from. And then if I divide this by x to the negative 2/3, that's the same as multiplying this by x to the positive 2/3. So again, if I divide this by x to the negative 2/3, it's the same as multiplying it by x to the positive 2/3. So if you multiply x to the 1/3 by x to the positive 2/3, you just get x. So that's where that extra x comes from. That extra x is what you get when you divide x to the 1/3 by x to the negative 2/3. And then of course we still have the 2x. So you have the 3x from the division, and then the 2x was still there. I know that's a little complicated, but basically that's what you have. Now you have x squared plus 1 minus 6x squared, which is the same as 1 minus 5x squared. And remember, we divided this out of the numerator, but what I can do, you notice the 3 is in the denominator, so I'm just going to put it in the denominator. And this, if I move it to the denominator, I'll need to change the sign from negative 2/3 to positive 2/3. So I can move that term to the denominator as long as I change that to x to the positive 2/3. So basically in the numerator I get 1 minus 5x squared, and in the denominator I get 3x to the 2/3 times x squared plus 1 quantity squared. Now again, the reason we want to do this is so that we can take this problem and set it equal to 0 and find the zeros of the derivative. Okay, so here's another example. On this one, u is x squared and v is x cubed minus 8. So u prime would be 2x, v prime would be 3x squared. So you just take v u prime minus u v prime all over v squared. And then you just do some algebra here and simplify this numerator to get this polynomial that I got here. And then this is just squared. And then this actually simplifies to minus x to the 4th minus 16x on top. And then on top you can actually factor out a minus x, and so on top you get minus x times x cubed plus 16 over x minus 8 quantity squared. Now again, I challenge you to use a graphing utility, and I want you to pay close attention. See, if you set this equal to 0, you'll actually get two answers. One answer would just be x equals 0, and the other answer would be the number that makes that makes x cubed plus 16 equals 0, and that's roughly negative 2.5. So at those two values, I want you to notice on the graph, if you graph this function, I want you to notice that at those two values you get horizontal tangent lines. And if you don't quite get that, don't worry about it. We'll talk about it later. Okay, one more. This one requires both rules. So for this one, I have a quotient where this is the u portion and this is the v portion. So what I'm going to do is I'm going to use the quotient rule. So I'm going to take v times the derivative, v is the denominator, times the derivative of the numerator, and then I'm going to do minus the numerator times the derivative of the denominator. Well, what's important here is in this derivative we actually have to apply the product rule to calculate that. So the product rule for this derivative would be 5t minus 1 times the derivative of 3 minus 2t, which is minus 2, plus 3 minus 2t times the derivative of the first factor, 5t minus 1, and that derivative is 5. And then I just bring down the second term, this product times the derivative of 3t squared minus 2, which is 6t, the derivative of that 6t. And when I get to that step, and also I have the denominator squared on the bottom, when I get to that step, I finish the calculus. Now, what I have to do is do some algebra, and you can go through and do this algebra. I just did a lot of multiplying, adding, subtracting, collecting like terms, and eventually you'll get, for the numerator, negative 51t squared plus 58t minus 34 all over 3t squared minus 2 quantity squared. And if you want to try another one that uses both of the rules, the product rule and the quotient rule, then you can practice on this one here, and the answer is given for you to check your answer. I'll do another short video on this section that just shows a few applications of derivatives using these rules.